Welcome back to my YouTube channel. Today we will discuss TIFR exam question. Question is given that AN is a sequence and Bn is also a sequence and defined by AN equal to 2 to the power n plus 3 to the power n to the power 1 by n and Bn defined by n by summation of 1 by ai. Okay, then they find the limit of Bn. Okay, now solution. First of all, Bn equal to n by summation of I1 to n 1 by ai. Okay, so this equal to n by 1 by a1 plus 1 by a2 plus dot 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 plus 1 by an. Okay, so now 1 by bn, that is equal to 1 by a1 plus dot 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 plus 1 by an by n. Okay, and this equal to n and x1 plus dot 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 plus xn, where xn equal to 1 by en. Okay, for all n. Okay, and we know that by the Cauchy first theorem, first limit theorem, if limit n tends to infinity an equal to L, then limit n tends to infinity a1 plus a2 plus dot 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 plus an by n is equal to also L. Okay, applying these theorems, we have from here the limit 1 by bn as n tends to infinity, we have limit n tends to infinity xn. Okay, and this is equation number 1. Now find limit n tends to infinity xn. Okay, how to find? This is equal to limit n tends to infinity 1 by an. Okay, we have from 1 limit n tends to infinity bn, that is equal to limit n tends to infinity an. Okay, this is equation number 2. Now we find limit n tends to infinity an. Okay, and here given an equal to 2 to the power n plus 3 to the power n whole to the power 1 by n, that is this equal to limit n tends to infinity 2 to the power n plus 3 to the power n to the power 1 by n. Okay, now our target is that find this limit. Okay, then we get the limit of the bn. Okay, from equation 2. So use here Cauchy's second limit theorem, that is by the Cauchy second limit theorems say that if en greater than 0, okay, and limit n tends to infinity, en plus 1 by en equal to L, okay, not equal to 0, this implies limit n tends to infinity an to the power 1 by n is also equal to L, okay, applying Cauchy's second limit theorems. From here we have, now find the limit. First we find the limit this 2 to the power n plus 1 plus 3 to the power n plus 1 by 2 to the power n plus 3 to the power n, okay, that is. So only we calculate this is my an, here this an, okay, then we get also limit whole limit. This is equation 3, okay. Now find this limit. So limit n tends to infinity 2 to the power n plus 1 plus 3 to the power n plus 1 by 2 to the power n plus 3 to the power n, okay. So that is equal to limit n tends to infinity common 3 to the power n plus 1, okay. So 2 by 3 to the power n plus 1 plus 1, okay, and here we common 3 to the power n, so 2 by 3 to the power n plus 1, okay, that is equal to this is we have 3, okay. So limit n tends to infinity, so this is 2 by 3 to the power n plus 1 plus 1 and 2 by 3 to the power n plus 1, okay, and this is tends to 0 and this is tends to 0, so this plus 1 and this is plus 1, 0 plus 1 and 0 plus 1, that is 3 into 1 by 1, that is equal to 3. So we get limit n tends to infinity 2 to the power n plus 3 to the power n to the power 1 by n equal to 3 using this Cauchy's second limit theorem, this, okay. So we get limit equal to 3. So from 3 we have, from 3 limit of an equal to 3, okay, n tends to infinity, and so from 2 we have limit n tends to infinity bn equal to 3, okay. So answer of the question is B, okay.